we have two issues. Issue one is, to move forward, we're going to have to make this simple. Or make or consider only very simple sequences first. Let's just get rid of all the possible confusions and just focus on simple sequences. What's the simplest pattern in our examples that we had? I say the simplest one is where we add the same number every time. I think that was a manageable pattern. Everyone, hopefully, saw that pattern. And it's easy to explain. It's going to be easy to work with. I think that gives us a fighting chance. Not open it up to everything. So let's look at an example like that, where we're adding 3 every time. It's easy to see, easy to explain, easy to find the next one, easy to convince someone else. But now, even in that kind of sequence, we have a lot of different sequences that have the same jump every time. That's just one example. So in order to explain and analyze these effectively, I want to get the language that we're going to speak down first. So let's say clarify how we explain these patterns. So first of all, what we did in the previous example was explain the pattern in English, saying we add 3 every time. That was fine. But for the possibility of things getting a little bit more complicated, the English explanation could get a little messy, difficult to rely on. So we want to translate this to our mathematical language, which has shown to be more effective in working with numbers and explaining technical things. So for that, we need to just get some words together to help us isolate and refer to different parts of the sequence. We can't just say numbers, because there are the numbers in the sequence, there are the numbers that I add, there are all kinds of numbers floating around. So let's call them different things. So the numbers in the sequence, the actual sequence, we will call those the terms of the sequence. So 1, 4, 7, 10, 13, those are the terms of the sequence. The terms are the actual things in the sequence. Terms. Then I also have the number that I'm adding every time, 3 in our example. The number to add every time, we'll call that number the difference. The difference. So in our example, the difference is 3. So by giving names to the different aspects of the sequence, I am trying to avoid confusion, making it easier to explain. There's one more, and that is the position that the terms occur in. Always starting with 1 and going up by 1. So the number 7 is in position 3, and the number 13, the term 13 is in position 5. So those already have a word, the position. So there's another one we also have to just be aware of. So there are three things, three aspects of the sequence. The terms, the actual things that you see in the sequence, the difference, how much I add every time, and then the position that the terms occur in the sequence. So having different names for those things just makes the explanation more effective. Okay. Any questions so far while I make a new page? 3 words. Terms, difference, and position. Oh, people are happy out there. 1, 4, 7, 10, 13 as an example that we can look at. And they occur in positions 1, 2. I like to put brackets around my position so I don't get confused. What's the actual sequence and what is the position? And our obvious pattern is to add 3 every time, of course. Okay. So now I want to translate the pattern that I explained in English, add 3 every time, into my mathematical language. To do that, I have to give a name for the terms. So the term in position, let's say the position number that I'm interested in is n. You might be interested in position 3. I might be interested in position 100. I don't know which one it's going to be. So I want to leave it open, and let's represent that with an n. That is going to be named the term in that position. So somewhere over here, some position. Could be one of these, anywhere. We're going to call that A with a little n subscript. That's going to be the name for the term in position n. So that means that I now can have names for all of these. So if I look at my sequence, position 1, the term's name will be A1. And in our example, it's the number 1. Position 2, the term in that position will be A2. In our example, it's a 4. And so on. They now all have names, making it easier for me to refer to in general. You might have a specific example. Those are still their names. They just have actual numbers associated with them as well. But if I maybe don't know the sequence at all, I can still refer to different terms without knowing exactly what they are. So now, the pattern I claim in my mathematical language is going to be to get, let's just leave this blank and just go at the bottom here. Sort of, let's do some rough work and see what the general pattern is. To get, I'll write these at the top. What were they? 1, 4, 7, 10, 13. To get 4, I had to take 1 and add 3, right? To get the second number, I added 3 to the first one. To get the 7, I took the previous 4 and added 3. And let's maybe do one more, squeeze it in there. To get the 10, I took the previous 7 and added 3. By way of their names, this first one means to get A2, I would have to take A1 and add 3. To get the next one, 7 is the third term, has name A3. I would take the previous term and add 3. And that last one, to get 10, which would be the fourth term, I take the previous term, which would be a third position, plus 3. And I can keep going like this. So in general, to get the term in position n could be any position, I still do the same kind of thing. What do? I use the previous term What is the name of the previous term? Yes.
Would it be an minus 1?
N minus 1. If I'm in position n, the position right before that is 1 less. And then I add 3. So it's just a generalization of the specific example that we saw. But now I can write it in one line, letting the position be whatever you want it to be. It's always look at the previous one and add 3. Look at the previous one and add 3. So our first goal is to understand what this pattern, how we're saying this pattern. And we're going to call that a recursive formula. Recursive because it's using terms that happened previously. That's recursive. Any questions on how to read that recursive formula and why it is what it is? That we're doing the same thing we did in English, adding 3 every time. Or more specifically, taking the previous number in the sequence and adding 3 to get the next. We're just saying it in a more precise way that would allow us to go a little further. Now, if you didn't know the sequence in our example, and I just tell you, make a sequence where you add 3 every time, are you going to be able to make that exact sequence? By just having the information, add 3 every time. Why not? I need to know where to start, or it's going to be many different kinds of sequences. So in a recursive formula, there is one thing missing, and I need to know the starting position. Together, they make the recursive formula. That if I say start with a 1, and then add 3 every time, then everyone's going to make the same exact sequence. I need both of those things. I need to know where to start, and I need to know how to go from one to the next. So recursive formula comes with 2 parts. Any questions on that recursive formula and what it is trying to say? What it is trying to say. So there's a lot of background things we have to get up to speed with how we're going to represent and explain these patterns. Any thoughts?
Why is it called a recursive?
That's the word whenever you are using previous things to find new things. Not sure if that's an obvious word. That's the word. Things are recurring again. I don't know. Recursive means you're using previous things already there in the sequence. And because of that, I need to have something in the sequence. So let's use our exercise 1.3 to really see if we can read these recursive formulas. Exercise 1.3, number 1. It's telling me, like it should, the first term, and then it's giving me the information to go from one to the next. But it's also throwing a little extra bit in there. So I'm going to make the first 5 terms in the sequence. So I'm trying to use the right words to get used to the words. Term, difference, position. The question says make the first 5. So that's what we will do. But it already tells me what the first one is, so I can just put in a 2 there and then. Easy. That doesn't look like a 2. Now I have to use the second part of the recursive formula to find determine position 2. Well, this one, I'm looking for A2. That's its name. Its name is A2, right there. But I want to know what the number is, hiding behind it. The recursive formula says, well, in this case, n is 2 for the next little while, because I'm interested in finding position 2. Use the one before that, which would be A1, and add 3 times the position I'm in. So the position value, the n, changes depending on what number I want to fill in. Right now I want to fill in the second position, so for the immediate future n is 2 in my recursive formula. What would you say is the number, the value of the term, the answer for A2? What would you say? He says 8. Who agrees with him? Who disagrees with him? Who has no idea what's happening? All right. That's important. I need to know these things. Which part are we not sure about?
Just all the A's.
Just all the A's. Fair enough. So our goal right now is to find this guy. Position 2 is all I care about. I'm in position 2. I'm standing right there. There I am. I have a little cloud around me. I have a question mark. I'm looking. What is there where I am? What is that number? Apparently my head is detached from my body. Okay, so in order to find that, I have to set the position to where I am, which is 2. So right now, n is equal to 2, because that's where I'm standing. N is the position, n is equal to 2. So then I use that in my recursive formula. There's an n, it gets a 2. There's an n, so 2 minus 1 is 1. And there's an n, so it gets a 2. N occurs there, there, and there. They all are 2 right now. So that gives me the calculation to find what number is there where I am. But it says use A1, which is this guy, because that's in position 1. 2 plus 3 times another 2, which is 6, which is 8. So then I have to erase myself. Whoop, that's a zoom, that's not an erase. What's the erase button? That's the erase button. Not a very big eraser, but it'll... Whoa, what happened? 8. Does that help a little bit? We don't have to understand everything very quickly as long as we're getting closer. This is new and strange and weird, but it allows us to talk about sequences and patterns more effectively. What would the next one be? Well, maybe you're not ready to just do it in your head. Now if I'm standing over here, I'm in position 3, looking to find A3. So yes, all the terms are named A. It's the subscript that tells me which A, where. It says, look at A2 and add 3 times the position I'm in, which is 3. It's confusing. It happens every time. It's just new. It's just new. If you're doing day 1 in a Spanish class, That is a very frustrating time if you've never done it before. It's the same, it's just a language. And then you look back months from now, how did I ever struggle with those basic sentences? It's all just where you are in the journey. Frustration is okay. You can throw phones if you want. But it's hard to learn to be okay with being frustrated. It's hard. Don't know how you learn that. It's time. What would you say is the number I should write in here?
17.
It is 17. It is 17. Now, can we do that one? You can scribble stuff. Do what you need to do. Do it all in your head. Do all kinds of scribbles. Doesn't matter to me. Use a calculator. I don't care what you do. Can we use the recursive formula to find what is next? What is in position 4? Now it takes like 30 seconds because not everyone does it equally fast. So I will let you know when I want an answer. And if it takes you longer, that's fine too. It takes time. It takes time. That's okay. Like 10 seconds. Is the countdown putting more or less pressure on you? 5, 4, 3, 2. What would you say is that number? She already said it. 29. 29. Because I'm taking the previous 17 plus 3 times the position, which is 3 times 4 is 12. 17 plus 12, 29. So then the next one is going to be 29 plus 15 to give me 44. Now you don't have to do it in your head right now. It's brand new. It's okay.
Are you going to write it out?
I want you to write it out. You write it out first and see where does it not work. How to get to those numbers. Because we have to get from copying to writing it down yourself. And it's hard to know when you're ready for that, so you might as well just try. The thing with math is it's frustrating sometimes to put in time and it seems as if you get nowhere. But somehow stuff still happens and progress is there happening in the background, even though it doesn't feel like it. So it's okay to not get it completely, but as long as you try, there's a lot of benefits from that. So let's just copy this down so we can see it. Also, when you're writing this, make it very clear that that -1, for example, is in the subscript. It's not like this minus. This is a big one. This is a little one. Okay. So here, if I look at the recursive formula, it takes the terms that are previous and the one before. n-1 is the position right before, n-2 is the position before that. Which is why they give me 2 starting numbers. So 1, 2, 3, 4, 5 I still need to make. Here is my position 1, 2, 3, 4, and 5. So the first one is 2, the next one is 5. They give that to me. If I want to find the third one, I am looking at n equal to 3 temporarily to find a 3. To do that, it says use a 2, 3 minus 1, minus 2 times a 1, 3 minus 2. So that is going to be the 5 minus 2 times the first term 2, and I get a 1. So 1. So right now it's all about reading the language, understanding what the formula is trying to tell me in how to make the sequence. It's very quiet, which is not a good thing. How do we feel about that? Does it make sense now that I do it, maybe, or something? Or maybe you got it already, and this just confirms it, or maybe you didn't bother to look at all. In any case, does it make sense now?
Where's 2a from?
That is in the formula.
And the
2 times whatever this number is. That's the formula telling me that. Right? Yeah. And then A1 happens to be a 2 as well in this case. But probably not in the next one. If I now want the 4th position, I set n equal to 4 to find A4. And the formula tells me it's the 1 before that minus 2 times the 1 before that. So it'll be a 1 minus 2 times 5 to get 1 minus 10 is negative 9. Oops, that does not look like a 9. Negative 9. So, you may be concerned about your grade. You may be concerned about certain quizzes that are coming up. First question on quiz 1 is, here is a formula. Make the first 5 terms in the sequence. So we have to be able to read the language, read the formula in what it tells me to do. So I'm making it worth your while by putting it on the quiz. You are welcome. Any questions on the negative 9? We can't be quiet on day 3. There's like day 60 coming. Yes?
just go over one more time why it's like 2 in brackets 5. Like I'm just confused.
So the formula at the very top says subtract 2 times some number. So instead of a times symbol, I use brackets. Still times. 2 times 5 because A2 is the term in the 2nd position, which in this case happens to be a 5. So 2 times 5. I just don't like the times symbol. It looks like an X. I don't like it. I like brackets. But it's multiplication here. Then if I want the last one, oh, can we do it without? You don't have to write any of that down. You just need to make the sequence. Can we do it by simply saying in words what the formula is asking me to do? Looking at the top, the formula is asking me to take the previous term and subtract 2 times the one before that. So if I'm in position 5, I want to find out what that term is. I take the one before that, negative 9, and subtract 2 times the one before that, which is 1. So negative 9 minus 2 times 1, negative 11. So you don't have to do a whole thing. Just rephrase the formula in words, and it tells you what to do and how to combine previous numbers. Anyone not okay with negative 11? You can write it down. I'm just saying you don't have to. Don't feel forced to. If you're interested in position 5, you would technically set n equal to 5 to find A5. The formula then says to use A4 minus 2 times A3. A4 is negative 9 minus 2 times A3 is 1. Calculator, if nothing else, says negative 11. Any questions? Maybe it's quiet because it's too easy. That's obviously the reason. Can't be any other reason. Okay, so that's one side of it, where we have these kinds of formulas. Remember, they're called recursive formulas, where I'm using previous terms to find the next terms. But it doesn't have to be like that. We also have formulas like example or exercise 1.4 number 1. A n is 3 times n minus 1. And you see this one only depends on the position. So formulas that only depend on the position, not actual other terms that happen. See, there's no other a on the right, only the position. They're called explicit formulas. And you'll see they're much easier to work with. So this is one of them. I still want to make 5 terms, but they're going to be much easier. You'll see. And those are the formulas that we're ultimately going to work with because of their convenience and mathematical simplicity. You can't get too fancy, but still. So now if I want to find the first term, it doesn't need to give me a starting number or anything. I just need to know which position I'm in, plug that position value in, and calculate what they say. In this case, they say 3 times the position minus 1. I don't think there's much to write down. What is the first term? 3 times 1 minus 1. So 2. All I need is the position, which is n. N is always going to be the name for the position. And then as I move on to different places, the position is going to change. So the calculation is going to give me a different answer. In position 2, n is 2. 3 times 2 is 6, minus 1 is 5. In position 3, n is 3. 3 times 3 is 9, minus 1 is 8. In position 4, n is 4. 3 times 4 is 12, minus 1 is 11. 3 times 5 is 15, minus 1 is 14. Does that make sense? Oh, that was a little fast. It is easier though. I'm not using the actual terms in the sequence. I'm just using the position where I am, plug it into the calculation, get an answer. That answer is the number that goes in that position. Recursive formula, when I'm actually using previous terms to make new ones. Explicit formula, just knowing the position, I can calculate the term in that position. Now you can of course have more calculations and scribbles there if you want to, but as far as a quiz question goes, you just need to make the sequence. You don't need to show anything else if you don't want to. Let us, whoops, what was that? Number 2, an equals 2n squared plus 1. What kind of formula is that? Recursive or explicit? Why is it an explicit formula? There's no a on the right side. There's only the position. There's no a, only the position. This is your time to shine. I am not making this sequence. You are going to tell me what the numbers are, one at a time though, so everyone can keep up. What is the term in the first position? What is the term in the first position?
15.
You can't answer my question with a question. 3, yes. That still sounds like a question, but I'll take it. Anyone not sure how to get 3? It's okay, it's new. It's okay. That's why we're here. You came all this way. If you have a question, you should ask. What is the term in the second position? She already answered, so she can't answer again. She's out for this one. I know why you're saying 5, but there's another 2 that you multiply with the 2 times 2, making it 9. There's nothing wrong with saying something that's a little incomplete. It's not wrong. They weren't happy with the 9. You don't have to be happy. You just need to eventually be happy in time for the quiz. I haven't asked my question. What is the term in the third position? What redemption? No redemption. Let me know if anything's not clear. I can't read your mind. If you don't say, I don't know. Fourth position. Now, you are welcome to use a calculator, whatever you need. What is the next number? 33. Does anyone support his 33? All right. And the last one. 51, 61? 51. I don't know, I thought I heard a 60. These are much easier in general to read and to understand what to do. You can use a calculator to do it. You just plug in the position number, position value, I'll say, and the number that you get, the answer that you get, is the term in that position. Okay. Explicit formulas are much easier, but the recursive formulas do happen, so I do need to know how to read them.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.